Somewhere in the constellation of Orion, one of the brightest stars in our night sky might already be dead. Betelgeuse is so far away that its light takes 548 years to reach us. That means the star you can see tonight, if you looked up, is actually showing you what it looked like over 5 centuries ago. If it already exploded sometime in the last few hundred years, we wouldn't know. Not yet. The light carrying that news simply hasn't arrived. Somewhere out there, one of the most dramatic events in the universe could already be on its way toward us, right now. To understand what we're looking at, let's start from here. Earth, at night, looking up at the winter sky. Orion is one of the easiest constellations to find, marked by 3 bright stars in a row forming its belt. Just above and to the left of that belt sits Betelgeuse, unmistakable for its reddish-orange color against the surrounding white and blue stars. Unlike our own sun, a relatively small, stable yellow star, Betelgeuse belongs to an entirely different class of object. It's what's known as a red supergiant, and it's nothing like anything in our own solar system. Let's get closer and see exactly what that means. Betelgeuse is classified as a red supergiant, a completely different category of star from our sun. It's roughly 700 times larger in radius, yet its surface temperature is actually cooler, around 3,600 degrees Kelvin, compared to the sun's 5,800. That lower temperature is exactly why it glows red instead of yellow or white. Despite being cooler, it's far more luminous, radiating over 100,000 times more energy than our sun. It achieves this simply through sheer surface area. Imagine a light bulb the size of a house versus one the size of a pinhead. Even if the house-sized one burns cooler, it still puts out dramatically more total light. To really understand the scale here, let's try something. Imagine removing our sun entirely and putting Betelgeuse in its place, right at the center of our solar system. Mercury would be gone instantly, completely absorbed. Venus would vanish next. Earth, our home, would be swallowed whole, along with Mars. Betelgeuse is so enormous that its outer surface would extend all the way out to roughly the asteroid belt, and by some estimates, even close to the orbit of Jupiter. Over 400 million suns could fit inside its volume. This isn't just a big star. It's a star so large that our entire inner solar system would simply cease to exist inside it. Here's something counterintuitive. Betelgeuse is astronomically young. Astronomers estimate it's only around 8 to 10 million years old. Compare that to our sun, which has been burning steadily for 4.6 billion years and still has roughly 5 billion left to go. Yet Betelgeuse is already nearing the end of its life. The reason comes down to mass. The more massive a star is, the faster it burns through its fuel, and the shorter its total lifespan becomes. Betelgeuse is around 16 times more massive than the sun, which means it's burning through its core at a dramatically accelerated rate, living fast and preparing to die young by cosmic standards. In late 2019, something happened that caught the entire astronomy community off guard. Betelgeuse began dimming dramatically. By February 2020, it had dropped to about a third of its normal brightness, the faintest it had appeared in over a century of recorded observations. Astronomers around the world scrambled to figure out what was going on. Headlines speculated it might be the beginning of a supernova. Social media exploded with theories that we were about to witness a star die in real time. For a few tense months, one of the brightest stars in our sky seemed to be fading away right in front of us, and nobody knew exactly why. Astronomers raced to figure out the cause. The most dramatic theory suggested this was the very beginning of core collapse, the first visible sign that Betelgeuse was starting to die. But as more data came in, a different explanation emerged. Researchers using the Hubble Space Telescope found evidence that Betelgeuse had ejected a massive plume of hot plasma from its surface, which cooled and condensed into a giant cloud of dust. That dust cloud drifted in front of the star from our point of view, blocking a significant portion of its light. It wasn't the star dying, it was the star sneezing out an enormous cloud of its own material directly into our line of sight.
Even though this particular dimming turned out to be dust, Betelgeuse's actual death is still coming. And when it happens, the mechanism will be nothing like a slow fade. Inside its core, the star has already burned through its hydrogen and is now fusing progressively heavier elements: helium, carbon, oxygen, all the way up to iron. Once the core becomes iron, fusion can no longer release energy, it absorbs it instead. Within seconds, the core loses the outward pressure that was holding the entire star up against gravity, and it collapses in on itself catastrophically fast, falling inward at roughly a quarter of the speed of light in less time than it takes you to blink.
Once the core collapses, the outer layers of the star come crashing down on top of it at incredible speed, and then rebound violently outward in a shockwave of unimaginable force. In less than a second, Betelgeuse would release more energy than our sun will produce in its entire 10 billion year lifetime combined. The star's outer layers would be blasted outward at tens of thousands of kilometers per second, briefly outshining every other star in its host galaxy. This is a core collapse supernova, one of the most violent and energetic events the universe is capable of producing, and it would happen almost instantly, without warning, once the process finally begins. If Betelgeuse went supernova, the light show from Earth would be unforgettable. Astronomers estimate it could shine as bright as the full moon, concentrated into a single point of light in the sky. It would be clearly visible during broad daylight for several weeks and bright enough at night to cast visible shadows on the ground. For months, possibly over a year, it would remain one of the brightest objects in our sky before gradually fading. People on Earth wouldn't need a telescope to witness this. They just need to look up. It would be, quite simply, one of the most spectacular astronomical events in recorded human history. So, with all this in mind, should we actually be worried? The short answer is no. Betelgeuse sits roughly 548 light-years away from Earth. Scientists estimate that a supernova would need to occur within about 25 to 30 light-years of us to pose a serious threat, close enough to strip away our ozone layer and trigger mass extinction. Betelgeuse is more than 20 times farther away than that danger zone. By the time any radiation from the explosion reaches Earth, it will be spread out across such a massive distance that it poses no real threat to life here. We'll get an incredible light show. Nothing more. There is one theoretical scenario that gets brought up whenever this topic comes up: gamma-ray bursts. These are extremely narrow, focused beams of radiation, so powerful they can be dangerous even across thousands of light years, but only if a planet happens to be directly in their path, aligned with the star's rotational axis. The good news is that Betelgeuse isn't the type of star expected to produce one of these narrow beams. That phenomenon is associated with a different, more extreme category of dying stars. And even in the rare scenarios where a supergiant does produce one, the odds of Earth being precisely aligned with that beam are astronomically small. This threat, for Betelgeuse specifically, essentially doesn't apply to us.
So when exactly will Betelgeuse explode? This is where things get frustratingly uncertain. Astronomers generally agree it will happen sometime within the next 100,000 years, which sounds precise until you realize that's an enormous window on a human timescale. It could happen tonight. It could happen 1,000 centuries from now. Some recent studies have suggested it might be closer to the earlier end of that range, possibly within the next few thousand years, based on models of its current internal instability. But the honest truth is, we simply don't have a way to predict the exact moment. Every night you look up at Orion, you're looking at a star that's already living on borrowed time. Here's the part that makes all of this even stranger. Because Betelgeuse is 548 light-years away, the light we see tonight left that star around the year 1476, decades before Columbus ever crossed the Atlantic. If Betelgeuse exploded at any point between then and now, the light from that explosion is already racing toward us through space, and we simply haven't received it yet. It's entirely possible that Betelgeuse has already ceased to exist as we know it, and Orion's shoulder is currently occupied by a star that isn't there anymore. We would have no way of knowing until the moment that final burst of light finally reaches Earth's night sky. After the explosion fades, weeks or months later, what remains won't be a star anymore. Betelgeuse's outer layers will be blasted outward into space, forming a massive, glowing supernova remnant that will slowly expand for thousands of years, potentially becoming one of the most spectacular nebulae in our night sky. At its center, the crushed remains of the core will likely form a neutron star, an object so dense that a single teaspoon of it would weigh billions of tons. Given Betelgeuse's exact mass, most models suggest it falls just short of what's needed to form a black hole. What was once one of the brightest stars in the sky will become one of the smallest, densest objects in the universe. So the next clear night, if you can, look up and find Orion. Find that reddish star marking its shoulder. What you're seeing isn't just a star. It's a message from 5 centuries ago, carrying no guarantee it's even still there. Somewhere between now and the next 100,000 years, that light is going to change, and humanity will witness one of the most extraordinary events the sky has ever offered us. Whether that happens in your lifetime or 1,000 generations from now, nobody can say. But the universe rarely announces its biggest moments in advance. Subscribe. There are far stranger stars out there still waiting to be explored.